My name is Ajashwan. My roll number is 24BQ180402. And my seminar today is on shift registers, the data modes of digital systems. This is a core topic in sequential circuit, and we will explore how these simple components manage data storage and movement in virtually and digital electronics. This we have four topics. First one, SISO, serial in, serial out. Second one, SIPO, serial in, parallel out. And the third one, PISO, parallel in, serial out. And the fourth one, PIPO, parallel in, parallel out. To appreciate registers, let's briefly recall the circuit types. We have combinational circuits which are memoryless. They react only to the present inputs, like a calculator producing a result instantly. But most complex system needs sequential circuit because they require memory. These circuits of output depend on the present input and the history of previous inputs stored in elements like flip-flop. A shift register is simply a clever organized arrangement of these memory elements, designed specifically to hold and manipulate group of bits. We move on to the another topic. What is shift registers? Definition. A group of interconnected flip-flops used to store and shift binary information. This means a shift register is a chain of interconnected flip-flops. The fundamental building block is the D flip-flop, and where one D flip-flop store one bit of binary data. It means function involves two actions. Data movement. Moving the stored data one position to right, left, or right with every clock pulse. And and this is the core component. The D flip-flop. The D stands for data. It is a one-bit memory unit. The D flip-flop only changes state when triggered by the clock. The output Q will take on the value of input D only. When the clock pulse transitions, for example, on the rising edge. The main key points are function. The simplest flip-flop for data storage. It acts as one-bit memory unit. Operation. The output Q takes the value of the input D only when the time requirement is for this D flip-flop is for an n-bit word, say 4 bits. It takes n clock pulse to load the entire word. Once loaded, it takes another n clock pulse to shift all the bits out one by one for the last flip-flop because it takes time both to load and read the data. Its primary use is as a time delay element, delaying a signal by precise number of clock cycles. This is all about day flip-flop. Now moving on to our topics. SISO, serial in, serial out. Now we look at the four modes of operations. Operation. The operation of this is data enters one bit at a time into the first flip-flop. And output data exists the register one bit at a time. typically for the last flip-flop operation. For an n-bit word, it takes n clock pulse. Primary usage used as a time delay element. And moving on to the next one, serial in, serial out. The input process is the same as SISO. Data enters serially over n clock pulses. However, the key is the output. Once the word is loaded, all n bits are available simultaneously at the parallel output. This is essential due to data transmitted over a signal wire like Wi-Fi chip or a modem is in a slow sequential stream. The CPO register converts this stream into a full byte of or word that a high-speed CPU can process all at once. It is the standard component for receiving data. Now, serial in, parallel in, serial out. The, the input is fast. In this, the input is fast. A whole word is loaded into the register in one single clock pulse using dedicated parallel inputs. The output is slow. The data is then shifted out serially, one bit at a time. On subsequent clock pulses, the piezo is used in transmitting data. It takes the fast parallel output from a processor and converts it into the necessary single stream format for sending across a long wire or communication channel. This is the diagram for parallel in and serial out system. Moving on to the another slide. The PIPO register is the simplest conceptually. Both loading and reading are done in parallel. It is primarily used as temporary storage unit or a buffer. The loading is done in one clock pulse only. It does not perform a conversion, but it is useful for holding data between two different parts of a system that may need to temporarily pause or synchronize their operations. And then these are the another shift registers called universal shift register. To maximize flexibility, we have the universal shift registers. The single sophisticated IC is designed to perform all four operations, like we discussed above. Pulses functions like clearing and holding the data. The mode is controlled by dedicated mode control input. Small binary selection lines by changing the voltage on these lines. You instantly configure the register to the more control mode inputs. Small binary selection lines by changing the voltage on these lines. You instantly configure the register to shift left, shift right, load parallel data, or simply hold its same state. A common example is the 74LS194 IC, which provide maximum versatility in a single component. At this end, let's take about to look about the summary. We have seen four types, differentiated by the speed of their inputs and outputs, and their main function conversion or buffering. The impact of shift registers is huge. Their key applications included data conversion, sequence generation, arithmetic. Data conversion means forming the essential physical layer for all serial communication standards like USB, Bluetooth, and Ethernet. And when it comes to sequence generation, creating specific digital timing pattern needed to control motor or display screens. And for arithmetic, they are fundamentally to how digital systems perform binary multiplication and division through bit shifting. Thank you for the opportunity.